Hi, how are you doing? Welcome to my daily live session on various topics for execution, excellence, and let me first introduce myself and then talk about the topic for the day. My name is Dinakar. I'm the founder of Samutana and the inventor of DoHow, a methodology for inspirational persuasion of teams to achieve amazing outcomes. Basically, we help teams achieve amazing outcomes, challenging goals by first getting everybody aligned towards one direction, and after that, taking them along. As they do that, they develop their personal, professional, and people competencies. And in doing so, we use multiple methodologies. One of them is Do How, gamification of brainstorming, I can say, and also cascaded mentoring and coaching, which is necessary for deployment. So if you are interested in checking out what it is, please do visit my website dinakarmurthy.com, and then you can find out a little more about what we do and about the new cascaded consultant coaching. So with that brief introduction, I would also like to share my email in case you want to write to me. Dinakar@samutana.com is my email. And the topic for today is simultaneous engineering. I think it's something not so, what should I say, new. Simultaneous engineering used to be the talk of the town in the early, late 90s and early 2000, when people would talk about trying to develop products together in one cross-functional team with multiple functions. And after that, now it is more or less kind of a standard practice in many world-class companies. But there are a lot of other companies where they still have a big difficulty in introducing simultaneous engineering. So I'm talking about simultaneous engineering from that perspective. And for those of you who are doing simultaneous engineering in a fantastic way, compliments to you. And today my job would be mainly to introduce simultaneous engineering, and tomorrow it would be about the application of simultaneous engineering, and day after tomorrow, Wednesday, would be on the cons or negatives, and Thursday would be on pros and positives, and Friday would be a dialogue with me on simultaneous engineering. That's the agenda which I did last week. This week also I do the same thing. And normally all these new initiatives will take some time to really, what should I say, start growing. So I wouldn't have any problem in waiting for some time. So let's see this Friday, if one of you is interested, you can come to me for a dialogue by visiting dinakarmurthy.com slash dialogue on Friday, though, not today. So with that very brief introduction, let me directly jump on to the topic. What is the topic which I am talking about is simultaneous engineering. What does simultaneous engineering mean actually? See, in any organization, when any product has to be produced and sold and launched in the market, then one needs to do the development activity. Conventionally, this development was done in a sequential manner, where you would start with the uh, functional development, where a sample would be made, and then that would be manufactured in the proto shop, which would be totally kind of a secret department in any company. And from there, some amount of functional samples would be done, and after that, the what you call as the tasting samples would be given to the customer for customer to try it out. Then there would be samples for doing field trials for basically checking out whether it really works or not. And finally, there would be samples coming out uh, from a manufacturing setup which is close to the final manufacturing setup. And then finally, the last sample would be from the final manufacturing setup, which would involve the actual machines purchased. So there are totally four stages of samples. First is the functional sample, second is the sample for testing the functionality, and the third would be the sample for testing in the field, which means it has to have a little more endurance, and the fourth would be the sample coming from the manufacturing setup, which is similar to the final manufacturing lines, and the fifth would be the one coming from the final manufacturing line itself. I said 4 samples. The first one was mainly a kind of a research and R&D which is done within a company which doesn't really go to a customer. So the customer samples would be 4. Now, this particular process is also very, very evident today in the software industry. Now, I basically transgressed to software from manufacturing, and there it is called as DevOps. I don't know whether you heard of the word DEVOPS, DevOps. DevOps is a combination of development and operations. That's the final dream situation where the guy who's developing it is continuously getting bombarded, getting challenged by the operations guy, so that whatever you develop, it becomes more robust. That is one of the fundamental principles of simultaneous engineering. I think the late 90s, mid 90s, jargons like DFMA got into the industry, which stands for Design for Manufacturability and Assembly. And I remember the idea of making a product manufacturable was the core activity of R&D, not just functionally meeting the specification, because it could functionally meet the specification but cannot be mass produced. Therefore, it doesn't really help the industry at all. It's not really a business model to be working like that. So therefore, the manufacturing industry went on to talk about simultaneous engineering, which is where you try to get all the functions involved in the running of a business of a product. It's not about just developing a product. You would have the R&D department, the endurance department, the endurance trials, the application department, the manufacturing engineering department, the order planning department, custom order planning department, the logistics department, quality assurance department. All these functions come together in the initial phase of the development. If you see the graph there, the resources are very high in the initial stage, even before SOP. SOP stands for start of production, and ramp up for the ramping up of the production. Now, in the normally, what would happen is you look at the green line here. Green line talks about the economically viable capacity, viable resource. That means for running a particular line, you don't need so many people standing near the line or for that particular product. And whereas during the initial stages, you would need more people. So the resources have to be planned upfront. And in doing so, the biggest advantage of the simultaneous engineering is seamless ramp up, and definitely very, very satisfied customer, because always the idea is to really see if that can be applicated and it will work, and also it can be produced or not. Now the same concept got transferred to software in the DevOps. I would say, what should I say? What is the word for that? Philosophically, where the software developers would basically develop a particular program, which then would be deployed by the operations guy. So the operations and development team work together. And in the software, it went one step ahead in talking about doing agile development. And in manufacturing, hardcore product industry, agile development is definitely done in a slight way. Again, it's something new. It's been there in vogue for quite a long time. I remember agile development, the principle of agile development being in vogue in manufacturing in the late 90s, early 2000s, when I was in the hardcore manufacturing activity, where we had to really test out whatever idea you got, because when you are doing the product development, a lot of new ideas keep coming up. So whenever a new idea comes up, you need to test it out, find out if it works or not, and that cycle had to be done within 2 to 3 weeks. In the software, it is much easier because it's only a question of writing a program. There is no physical, what should I say, creation of anything. Whereas in the manufacturing, you have to create physically. That means if suppose you say that I want a hole to be done at 60 degrees instead of 80 degrees, it means that you need to start from the scratch, and or maybe when you have already drilled the hole, fill it up with some kind of a welded material and then re-drill the hole. Whereas in the software development, it is just erasing a set of code lines and writing new code lines. That is much easier. But still, I'm not trying to really compare which is easier, which is difficult. But I'm trying to say that the concept, the principle of agile development was already there in manufacturing in the 90s and 2000. Though I don't know what agile development in the software is, because I'm not exposed to software agile development, but I can imagine what it is, because you're talking consistently and continuously of trying to clear small packages which would be improving the overall performance of the product or the service. I remember in our ratio development act in the ratio project planning, we would call it as RPP, ratio project planning, for reducing the cost of the product, because we had huge problems in the ramp up of Common Rail in the 90s, late 90s, and that's when I was really, what should I say, my life used to be crazy with 80 to 90 hours a week, because of the huge demand, and we were not able to meet the demand, and our production was not very stable. Therefore, in the early 2000 and all for half of 2000 to 2006, my job was to see if we can do any development of manufacturing processes in advance. So that's what I did, advanced technology development of manufacturing processes, for ensuring that the SOP becomes a little more smoother, because we had a lot of new technologies, new processes, new machines. We were not knowing what it is, and the yield is first pass yield of a product once it is assembled would vary between 27% to 90%. Some days it would be low, some days it would be high. Till you really dominate that, it's really a challenge. All this could be done if the simultaneous engineering can be done from the beginning. That is the whole idea. With that, I look forward to talking again tomorrow. So thanks a lot for joining, and for those of you who are here, Winston, thanks a lot for mentioning that creativity is the name of the game. Absolutely, creativity, and more than creativity, it is application of creativity. Just being creative doesn't really help. You need to really applicate that and find out what happens, and then learn from that. That would be the ideal thing. I'm sure you would have meant the same. So with that, thanks a lot for watching. Those of you in India, have a nice evening. Those of you outside India, have a great day ahead, and see you tomorrow again on applying simultaneous engineering. Where can it be applied? How can it be applied? What have been my experiences? I'll talk about that. Thank you so much, and goodbye.